Alright, in this video we said we are going to develop the principles of this vertical system further. So this is what I'm going to do. I'm just going to take this diagram that we had and I'm going to redraw it, but in a simplified version. And I'm also going to turn it like this because this vertical system respects the observer's orientation. So I'm just going to make the observer face upwards like this. This is how I'm going to draw it. I'm going to draw with the observer facing up, so that is horizon. Because you know that this is the vertical axis, and in the previous video we said the great circle that is perpendicular to the vertical axis of the observer is called the observer's horizon. So I'm just going to draw the horizon in and these poles so that you see what we have. So drawing that in, I'm drawing that diagram in a simplified version. We are just going to, the observer is going to be somewhere in the middle there, but their axis is going to be like this, because this is going to be their zenith and this is going to be their nadir, and they are going to have a horizon, the great circle that is perpendicular to this axis, to their axis, the zenith nadir axis, or their vertical axis. And as you can see from this original video, the north and the south will be lying on that at that angle. So we are going to have the north and the, so this one will be the south celestial pole and this one will be the north celestial pole. They will be at an angle like this, making the celestial axis. So this is the celestial axis, this is the vertical axis, and this is the observer's horizon. And as you can see now, in this simplified diagram, this is the north celestial pole, zenith, south celestial pole, and nadir. This circle that is outside is passing through those points, and therefore this is called the observer's celestial meridian. The one that is outside is the observer's celestial meridian, this one, the circle outside. I don't want to label here because we are now going to define our angle, so it might become too difficult to see. Now, can you see the celestial meridian? And this is the horizon, remember? This is the horizon. But can you see the celestial meridian is cutting the horizon at 2 points. It's cutting the horizon at this point and at this point that are right there. So now, the celestial meridian cuts the horizon in 2 points. One near the south celestial pole and the other near the what? The north celestial pole. The one that is near the south celestial pole is called the south point. It's called the south point, and the one near the north celestial pole is called the north point. It's going to be called the north point. So now, if this observer is in the northern hemisphere, this is one thing you now need to know. If this observer is in the northern hemisphere on Earth, they will be seeing a situation like this. The north celestial pole will be like this. It will be above their horizon. They'll be seeing the north celestial pole. They'll be now this is something that I didn't mention because I didn't think it was useful at the beginning, but on the north celestial pole there is a star called Polaris. There's a star called Polaris. So if they're in the northern hemisphere, they will see this star called Polaris. Anything above the horizon is obviously, as intuition says, it's something that you can see. If something is below your horizon, you cannot see it. That's why right now I cannot see what is below this table, because this table is limiting my horizon. I cannot see what is under this table. That's the same thing as what? As this horizon. Anything that is below here, this observer is not going to see, because they can see anything that is above the horizon all the way up to the zenith, because the zenith is on top of them, and this nadir is below them. So anything that is above the horizon, from the horizon all the way up to the zenith, they will be able to see. But anything here, they cannot see, because they will only see the ground. They only see the ground when they face down. I don't quite know what happened to my disk. I think I shook the table, so it stopped recording. But what I was basically saying is the origin is chosen as that point that is below the visible pole. So can you see this observer is seeing the north celestial pole? They are not seeing the south celestial pole because the south celestial pole is definitely below their horizon. So they are only seeing the north celestial pole because it's above their horizon. So the origin is chosen as the north point because that is the point that is below their visible pole. Their visible pole being the north celestial pole. So we are going to define our origin as that point. So after we've defined our origin, it's now a matter of defining how to locate the star, how to locate a star. So now imagine there's going to be a star right there. You know that we are going to need an X and a Y, or we're going to need, definitely we're going to need sort of like the X in quotes and the Y in quotes. So this is what we're going to do. Now we have an origin, so we need to know how far the star is from the origin, both in the X direction and in the Y direction. So this is what is going to happen in the terrestrial system. We took a point M, that was where that the point's meridian was cutting the equator, because our equator was our x-axis. But we mentioned that in this system our x-axis is the observer's horizon. That is going to be the x-axis. So this observer's horizon marks our x-axis. So it's a matter of drawing a vertical circle. We are not going to draw meridians. In this system, we draw vertical circles that connect the zenith, going through the point, passing the horizon, and going through to the nadir. Those are called vertical circles. So this vertical circle is the one that we are going to use to locate the star. How are we going to use it? We are going to use it the same way. Can you see it? What it cuts? It cuts the x-axis or our horizon at this point M. We are going to call the center C. So we are going to measure the angle OCM. How far along on the x-axis in degree terms is this point M? Is this point M from the origin? This is what we are going to measure. That angle OCM. So we are going to measure OCM. It's basically just like the terrestrial system. If you understand the terrestrial system, it will be easy for you to apply to this. Angle OCM is going to be is measured through east, because you know this is north, south, and then there's going to be our east and then our west on that side. So it's going to be our east and then going to be our west. So okay, here we're not going to measure through east because we are not in the southern hemisphere. We're going to measure through west because we're in the northern hemisphere, because we're only seeing the northern celestial pole. We're going to discuss that more in the next video, but right now we just want to define our angles. OCM. Our angle OCM is called an azimuth. It's called the azimuth. That is the angle. That is the name of that angle. The x coordinate is called the azimuth. And also, now that we've seen what this, we now need to know exactly on this vertical circle, where is this star, where exactly is it? So we need the elevation above the horizon or below the horizon. So this observer who is here, are they going to elevate their line of sight above the horizon to see this star? We are going to measure an angle. I'm going to call it MCS. So we are going to have an angle MCS. Our angle MCS is going to be the elevation above the horizon. It's going to be the elevation above the horizon for you to now pinpoint the star. We now know where which vertical circle it lies on, but we want to know on that vertical circle where exactly is it. So we are going to use this angle MCS as the elevation. And angle MCS is measured vertically from 0 degrees to 90 degrees above the horizon and is known as the altitude. So these are the two angles that we are going to use, the azimuth and the altitude. Now we've defined our x coordinate and our y coordinate. We're going to see them in the next video, how they are going to come into play. So stay tuned in for that video.